pressure head equal to work rho A into delta x, rho no, so P divided by weight rho G A into delta x. So delta x delta and A cancel. So pressure head equal to P by rho G. Understand? This is the pressure head. Understand? Now number two is kinetic energy per unit weight or kinetic head. Now we know this is square, V square, per unit weight. So we know the kinetic energy half mv square. So kinetic energy by weight or kinetic head equal to half mv square into weight equal to rho g into volume, rho g A into V. Kinetic energy per unit weight. This is rho into m. So cancel out, so V square by 2g. This is the kinetic. And number 3 is Z, potential energy per unit weight or potential head. Potential head equal to potential energy mgz, height is z by weight m into g. So mg cancel out, so potential head equal to z. This is now this is very important points. Bernoulli's equation represents conservation of mass, conservation of energy, conservation of energy. Now next is Bernoulli's equation for real fluid. Now real fluids are viscous and hence offer resistance to flow. Resistance to flow. uh, real fluids are viscous and offer resistance to flow. So there are loss of energy. There are always some loss in fluid flow. Always some loss in fluid flow. Suppose this is a pipe. Suppose this is E1, this is E2. Use energy. This is section 1, this is section 2. Total energy at section A. Total energy at section 1. This is the total energy at section 2. Suppose here is EL. This is the loss of energy. So loss of energy, and E1. So E1 minus E2 equal to EL. This is the, and this E1 by rho g minus E2 by rho g equal to EL by rho g equals to HL. This is the head loss or loss of energy per unit weight. Loss of energy, head loss. This is the head loss, energy loss of energy per unit weight, or loss of energy per unit weight, weight density. Rho g means weight density, or HL. So from here we can write P1 into rho g V1 2g plus Z1 equal to this one, these sides, so P and V2 square by 2g plus Z2 plus HL. This is the equation, Bernoulli's equation for real fluids. And here U1 is more, U1 is more than E2, so the float is taking place, flow is taking place from section 1 to section 2 means from section 2, and this is if the flow is from this side to this side, the HL is adding here. HL is head loss is here, add here, the right side. But when the flow is taking place from section 2 to section 1, means E2 is more than E1, that time the heat loss is add to the right sides. Understand? So we can write E1 minus E2 by rho g equal to HL. Now a question. Suppose a pipe carries the pipe is diameter is 4000 millimeter and velocity is 25 meter per second, and pressure at point A this and pressure at point B this respectively, and datum 28. Suppose this is the pipe diameter, and suppose this is the datum line. Suppose this is the pipe and this is the 28 meter, and this is datum is this is the this height is 30 meter, and pressure this is A. Suppose PA equal to pressure at this 29.43 and pressure at B point PB equal to 2.563, and the velocity and the diameter is 4000 millimeter, and this is the and this is the meter. This is Newton per centimeter square, and the velocity is 25 meter per second. Understand? Now convert Bernoulli's equation. The flow is point A2 and point B, so rho g plus VA square into 2g plus ZA. This is the ZA, this is the ZB equal to PB. This is the Bernoulli's equation for this is the real fluid. Rho g plus VB square by 2g plus ZB, and this side too, so H head loss. This is the loss of head between A and B. Velocity is constant, uniform, so this one same, they'll cancel out. And pressure at PA pressure 29.43, and rho value, this is water, density of water 1000. This is Newton per centimeter square, so this sign is convert Newton per meter square 29.4 into 10 to the power 4 Newton per meter square, so 10 to the power 4 into 1000 into 9.81. This is 28 ZA, and this is 25.56 22 points, sorry, 536 by 10 into 10 to the power 4, convert Newton per meter square into 1000 into 9.81 plus ZB is 30 HL. Understand? So HL equal to, calculate this one, this is 5 meters. So the loss of weight HL equal to 5 meter for the given problem.